Many teams who reach out to us don't just need a generic DICOM viewer. They need a workflow where MRI scans, AI segmentation, 3D visualization, and planning tools are combined in one custom interface. In today's video, I will be showing you one of the workflows that we can build, which is in the neuro space. I have here an MRI scan of the brain, and it's already open in the viewer. And basically, you have something that is standard in most DICOM viewers. So you have the MPR here, so axial, coronal, and sagittal views. You can scroll through them. You can go to specific slice and do some analysis on it. But usually, this is just the starting point for the workflows that we build for our clients. What we do after this baseline is adding things like AI segmentation overlay or building presurgical tools or some other tools depending on the use case. Now let's go over one of these workflows that I just mentioned. Let's say that you have some sort of an AI endpoint or AI model that generates different structures of the brain. So it segments all of the brain into different structures, and then you have some output file, and you want to visualize that output directly on the scan. For this, we have a module called label maps that basically whenever you load those segmentations, whether that be NIfTI based segmentations or DICOM SEG based segmentations, you can load them into the viewer and they will appear in this module here. Now, I have already loaded a segmentation file, but I'm just hiding the structures for now. So let me just show them. It should appear in a second. And here we are. So you have all of these segmentations coming from some AI model, and then you can see that they are overlaid on top of the volume on all of the three orthogonal views. Now, if you scroll, you can see those segmented structures. Same thing here and here. And you also have control over the opacity. As you can see, this structure here, we're slowly decreasing the opacity, or we can increase it. You can also just hide the structure completely. And of course, depending on the number of structures you have them basically listed here. Now, this is a NIfTI file, so the labels do not have names in them. So that's why it defaults to these names. So label 1, 2, 3, so on and so forth. If you have a DICOM SEG and that DICOM SEG contains real information about that specific segmented region, then you're going to get them here in this list and you'll be able to see whether it's liver or it's tumor or anything like that. You'll be able to see those specific names here. By the way, if you're looking to build a DICOM viewer for neuro space and you want to integrate AI segmentation into it, then I have something for you. I have created a checklist or a guide that helps you avoid some common mistakes on how to have these two different components work together. AI segmentation on one part and the DICOM viewer on the other part. So if you want to get that checklist, check out the description box. And we're not just going to stop here. Actually, we're going to render this volume in 3D and also render these 3D structures and visualize them in 3D. Usually, this is very important for pre-surgical planning or more advanced analysis. So let me just close this tab here. And first, let's go to volume rendering. And let me just click on render current volume. And here I'm going to click on CTA vessels. This is one of the presets that we have. Of course, we have some other presets, but they will not be useful in this use case. Now let me just choose MIP instead. When the structure looks dark, you can actually fine tune it. You have these values here that you can play with, and you can see that's how it looks. And now let's go to the 3D structures and let's render them. So let's click on this. Let's give it a few seconds to generate all of the 3D structures. So now it's taking them from the 2D scene, sorry, from the MPR, and generating 3D structures that will be overlaid here inside the volume. So it's taken a little while because we have so many different structures, but you can see them getting updated here. So a few structures have been added. Let's wait just a little bit longer. As you can see, we have 110 structures. Some of them are actually absent, so they're not here, but only a few, maybe 7 or 8 are absent. The rest are here. So definitely takes time to generate the 3D structures for all of those different segments. Okay, now it's finished updating, and as you can see, now we have the 3D segments here. And basically, you can see them inside the volume, and you can also just hide the volume completely so that you can focus on the 3D structures. So if we go back to the volume, let's click on this. Now you can see only the 3D structures here that have been rendered. And of course, you can do analysis on them, and you can also control the opacity from here, and you can see it, for example, for these structures, it becomes more pronounced. You also have the ability to look at all of the structures, all of the views at the same time. So here I have the MPR views at the top, and then I have the 3D scene at the bottom. You also have the ability to focus on a specific part and look at it from all the 3 different orthogonal views by using the crosshair tool. So here you can say, let's focus on this region here, and then you'll be able to see that the corresponding region in the other views can be automatically configured. And not just that, what you have here is actually an overlay of the orthogonal planes, axial, sagittal, and coronal, on top of the 3D scene. So this enables even more precise planning because you can focus on a specific region and not having to go back and forth between the MPR and the 3D scene. You can just stay in the 3D scene, and you can look at the structure there. And if you move it, you see that it moves. The planes actually move with the cursor, and basically they follow whatever you have in the MPR is being replicated in the 3D scene. One very important feature in most DICOM viewers is the ability to do measurements. So we have a module for doing measurements. It contains 4 different types of measurements: distance, angle, area, and volume. And we can even build more specialized types of measurements on top of this. And one neat functionality that we've added specifically for distance measurement is the ability to do measurements in the MPR and seeing it being updated live in the 3D scene. So let me just do one measurement here. And as you can see, I have the measurement also shown in the 3D scene. So you can do this on all of the 3 MPR views. And this is something that was actually requested by one of our clients. It's not something that we built by default, but it just shows you the level of customization that can be done in such viewers. Let me show you now one last feature that was requested by a client, which helps with basically conveying information and sharing and communicating different uh, types of information between different clinicians. So this is a module for annotations. And basically what it allows you to do, we have different types of annotations in this module. And basically it allows you to point to a place either by an arrow or freehand or a rectangle or a circle or just writing text. And then you can basically do something like this. So you point here and then let's say, check this out. Let's click OK. And now this is an annotation that is uh, basically drawn on top of the coronal view. And then if you scroll away from that slice, as you can see, it disappears. And when you come back, it reappears. And this can be very useful when, let's say, one doctor is reviewing a case, he sees something strange or something worth noticing. So he would point at it, leave a note, and then we have the ability to save this session state in the backend. And then it can be retrieved by a different doctor from a different organization. And when that other doctor goes through the case, he will see the notes left by the first doctor. So this is a very neat feature, and it can be very useful in a variety of scenarios. By the way, if you're looking to build a DICOM viewer for NeuroSpace and you want to integrate AI segmentation into it, then I have something for you. I have created a checklist or a guide that helps you avoid some common mistakes on how to have these two different components work together. AI segmentation on one part and the DICOM viewer on the other part. So if you want to get that checklist, check out the description box.